Good afternoon, Year 11. This video relates to exercise 14K of the text, called Further Symmetry Properties and the Pythagorean Identity. So when it talks about symmetry properties, what it's referring to is symmetry properties of the unit circle. So I have this prepared for us. This is the first quadrant of the unit circle. Okay. What I have here, the angle of 30 degrees, or pi on 6, is drawn in. And with pi on 6 drawn in, I'll just move that up. Maybe I need to zoom this a little bit. I'll see if I can do that, but we've got 30 degrees, or pi on 6 drawn in there. And we've got these values, and these values come from our standard triangles. The cos of pi on 6 is root 3 on 2, and the sine of pi on 6 is a half. Excuse me. Now this applies to any angle, or any pair of angles if you like, but it's just we're using pi on 6 as an example. So you can see here the coordinates, root 3 on 2 and a half, that's pi on 6, pi on 4 and pi on 3. So with this right angle triangle drawn in that first quadrant of the unit circle, if we draw a similar triangle up here, okay, so this angle coming down from the y-axis, if we make that angle pi on 6 or 30 degrees, what it means is that this length here, this side of the triangle if you like, is 1/2, and from that point there down to there, that's root 3 on 2. Okay, you've got two similar triangles there. So what that allows us to show is that this angle here, that's made by this pi on 6 here, from 0, trigonometrically, this angle is 90 minus theta, because theta is pi on 6, this angle here is pi on 6, so this angle, the angle made at this point here, is 90 minus theta, or actually pi on 2 minus theta. I've just realised I've got an error up here. I've got this drawn as pi. It's actually pi on 2 to make that correct. Okay, so the excuse me, the sine of pi on 2 is this length here, which is this length here. Okay, that length there, root 3 on 2, is the sine of, sorry, it's not the sine of pi on 2, it's the sine of pi on 2 minus theta. The sine of that angle is root 3 on 2, which is equivalent to the cos of that angle there. So you can hopefully see through symmetry that the sine of pi on 2 minus theta is the same as cos theta. And when we look at it the other way, the cosine or cos of pi on 2 minus theta, the cos of this angle, okay, the cos of this angle is a half, which is the same as the sine of this angle. So it's a property of symmetry there. A shorthand way of writing this is that it's actually easier to see this if you write this with degrees rather than radians. Sine of 90 minus theta equals cos theta. Okay, and cos of 90 minus theta equals sine theta. Now, sometimes it's easier to look at these in pairs and say, well, sine 60 equals cos 30, for example, and cos 60 equals sine 30. Okay. Now this could be any pair that both add up to 90. Any pair that both add up to 90, this is true. So that's like the shorthand way of explaining that. Did that come through on the bottom? Let's move that up. So yeah, you can see sine 60 equals cos 30, cos 60 equals sine 30. Okay, and you can replace that with pi on 3, pi on 6, pi on 3, pi on 6. There's other symmetry we want to look at as well. That's why I've got this one ready to go. Now, we've got an angle theta drawn in the first quadrant, okay, Now, if we actually do, it looks like a propeller, doesn't it? But if we draw that same thing up here, and we draw the same triangle there, and we draw the same triangle there, then these blue lengths here are equivalent. These 4 blue lengths are equivalent, and these 4 red lengths are equivalent. So this value here equals cos theta. This value here has the same. It has the same length. This value here is the negative of this. This value here. There we go. As in, it's the negative, but it has the same length. Okay, sorry, I nearly confused myself there. Now, this angle here is theta. What this angle here represents is 90, or pi on 2, plus theta. So I've got that here in the bracket. Theta plus pi on 2. That angle there represents theta plus pi on 2. This angle here represents pi plus theta, pi being 180. Sorry. Yeah, I've got pi there. I've got 2 pi. That's not right. It's only 1. So let's fix that up. Okay, and over here, we've got an angle in there. This is theta minus 90. This is here. This is theta again. Okay, so that symmetry goes all the way around. This is where we get some formula or symmetry ideas that are there in the book. What it's saying is that the sine of this angle, okay, if we just draw this angle round to here, the sine of this angle is the vertical component. So sine of this angle here is actually the red line, which is equivalent to cos theta. So this angle is theta plus pi on 2, or pi on 2 plus theta, doesn't matter which way you write that around. The sine of this angle actually equals cos theta. Okay, and we've got the cos of this angle. What's the cos of this angle? It's this distance here, the blue line. The cos of this angle is the blue line, which has an equivalent length to the sine of the original theta. Okay, so sine of 90 plus theta equals cos theta. Cos of 90 plus theta equals sine theta. Okay, but these, and you can do equivalent ones for all the way around the circle. So we've got some symmetry properties there. What you're asked to do with this is you're asked to solve questions. Okay, so for example, if sine theta equals 0.4 and cos alpha equals 0.7, right? Let's find the values of these things. So the sine of pi minus alpha. The sine of pi minus alpha is cos alpha. That's actually from this one. Okay, so this angle here, if this angle here is alpha, it's got theta in there. Okay, the sine of pi minus whatever variable equals cos of the original. So the sine of pi minus alpha equals cos alpha. And cos alpha equals 0.7. What is the cos of, I was meaning pi on 2 by the way, pi on 2 minus alpha. What is the cos of pi on 2 plus alpha? Okay, pi on 2 plus alpha, we go to this one here. Cos of pi on 2 plus theta, alpha, equals sine. So this one here equals sine theta. cos of pi on 2 plus theta is equivalent to sine theta, which equals 0.4. What's the sine of negative theta? Okay, if we look at this one here, the sine of theta is sine of theta. Sine of negative theta, if we just go down this way, it's negative sine theta. Which equals negative 0.4. Now, you're asked to actually do some questions related to this. Okay, there's a similar work example, example 24 in your book. The questions are not that difficult, but yeah, have another look, give it a go. The next thing that this exercise looks at is something called the Pythagorean Identity. So let's just write that in as our heading, the Pythagorean Identity. Now, for this one, I actually need a different picture. I need this picture. Here it is. What I need from here is this idea of an angle, okay? This triangle, right? So, tan theta here. And sine, sorry for that very pregnant pause. We've got any angle drawn in here. We've got any angle drawn in here, and we've got this value being sine. The blue value is sine. The black value is cos. Okay. Now, and the radius is of course 1. Now, if we apply Pythagoras' theorem to this diagram, remember that Pythagoras' theorem is c squared equals a squared plus b squared. Okay. Now, if c squared equals a squared plus b squared, and we look at this here, if we come into this particular diagram, and I wanted to use a pencil, there's my pencil. Okay. If we label that as side C, that as side A, and that as side B, this length, c squared, equals this length, a squared, plus this length, b squared. So for a unit circle, one squared equals sine squared theta plus cos squared theta. Okay. Now, we don't write it as sine theta squared or cos theta squared because we're not squaring the angle, we're squaring the value of cos or the value of sine. Okay. So this particular relationship, it's called the Pythagorean identity. A general statement like this is known as a trig identity or trigonometric identity. This is the Pythagorean identity. Okay. Sine squared theta plus cos squared theta equals 1. Now, one thing you're asked to do is you're asked to use this to solve for different values. So given that sine x equals 3/5, between pi on 2 and pi, find cos x and find tan x. Okay. So if we just plug straight into here, sine x is 3/5. So 1 equals 3/5 squared, all squared, plus cos theta, cos squared theta. Okay, so 1 equals 9/25 plus cos theta. Okay, that means cos theta equals, what's that, 16/25, which equals 4/5. Okay, or I've said theta, that's x. Alright, so I've found cos theta and I've run out of paper. Alright, if sine x equals 3/5, let's just work in the first quadrant for now. We're in the quadrant 90 to 180, so this is actually in the second quadrant. Okay, we'll keep in the first quadrant for now. Sine x is 3/5. Actually, it's easy. If sine x is 3/5, if we're in the second quadrant, then cos x is actually going to be negative 4/5. Alright, it's going to have a negative value. Okay, negative 4/5. So what I'll do is I'll flip that over and I'll do that again on here, and I'll say given that sine x equals 3/5 and cos x equals negative 4/5. Okay, find tan x. We have to remember here a ratio that tan x equals sine x over cos x equals 3/5 divided by negative 4/5 equals 3/5 times 5/-4, so that equals negative 3/4. That's tan x. Did that one fairly quickly. Okay. Have a look at that, another one of those if you need to. Okay, but that's the basics. That's what you're asked to do in exercise 14K. Also bear in mind that there's a short little summary on page 514 that you want to have a look at as well to help you make your notes. Not too many questions in this exercise. Give it a go. Shouldn't be too difficult. Thanks for watching.